Good morning, and thank you for joining this session. And I'm Chinmaya. So today I'm going to talk about embedding is all you need, right? And just before this session, we saw that how to set up the LLM systems in an Intel cloud, right? So let's understand what is behind that LLM system, okay? It's not presenting here? Oh, it went to thank you. Okay. So how many of you are using the e-commerce apps like Amazon, Flipkart, Myntra, everyone? Oh, very nice. So have you ever tried that something like I'm going on travel or traveling to Dubai and all. I want something like sunset-inspired evening shoes. Have you tried any apps? So what it comes? How it presents? Is it presenting like this? Right? Okay. But how do you think that when it comes like this? What's the difference? If you see this one, and this one. This one was more like only the orange and yellow shadows, right? But it was not understanding your intent. So let's talk about the story of Lucy, right? She is a big traveler. She travels across the world, and previously also she tried like yourselves, and she did not find the shoes or the other dresses which could have resonated with her thought process, right? So now she also tried like this sunset inspired shoes, and it came like this. But this time when she tried, this kind of shoes came up, which is really putting the sunsets colors or the gradients mirroring the sunsets. Also, you can see the sun rays, the calmness of the dusk. It is also there, right? It means the system understood what her feeling was, right? She is now heard. Now her shopping experience is elevated, right? How it is happening now? So that is where this embedding is coming, right? Embedding is all you need. That is my topic. So what is this embedding? You can see this is something like audio. Whatever you are talking, voice. You talk over phone, you talk to the customer care. This is images. These are something like text, what you are searching. And these are like some code bases, what you are writing, right? So everything can be converted into some kind of number, right? This is called as vector. These are the numbers over here. And what is this embedding? What is this term really? Because we have seen that in the embeddings are used in electronics and all, but embeddings are dense numerical representations of real-world objects and relationships expressed as vector, right? Vectors are nothing but these numbers. And this vector space quantifies the semantic similarity between categories. You can ask me questions if you want in between. You can pause me. Embedding vectors that are close to each other, I think this is hidden there, that are close to each other, they are thought as similar to each other, right? Like when it is converted into numbers, they are thought of as similar to each other when they are closely placed together, right? So this is a simulation of our books, right? Wiki books, where we can see that, okay, there are around 9,360 books, which are presented over the three-dimensional space and converted into embeddings, because embeddings are points, right? Those vectors are presented over here. And suppose somebody is searching over here, I want to find a book similar to Moneyball, or I want to find a book similar to Return of the Kings, right? Lord of the Rings, the book series. Then we can find what is there, what are the books similar to that is present over here, right? Like Return of the King. So it is a cluster created by putting down the numbers together into one place, right? This is how it works. So why do we need this, right? We talked about embedding, but why do we need this? Humans speak in the words, right? And we talk sentences, right? So, but how do computers understand those words or sentences? This is where the embedding comes. And these sentences or images or the code bases, those are converted into your numbers, right? Through a machine learning model. That is called, today's days, we are using large language models. Thanks to the OpenAI, they have invested a lot on the large language models. And they are giving us the word embedding, sentence embedding, which is presented as the numbers in the three-dimensional space. So that when we are talking or we are writing any queries, those are understood, those are semantically understood. It's not that we are just doing some kind of word matching or text matching. It is conceptual matching you are doing. Okay? So embeddings are useful for your working with natural language or images, code bases, because they are now related or compared with other, compared through other machine learning language models like clustering or some kind of search mechanism or search algorithms. With that, we can combine together and we can see that which text is similar to each other. All right? Now, how they are created. Okay? So before how they are created, there are different types of embeddings, like word embeddings, the sentence embeddings, the image embeddings, the voice embeddings, as well as the code, what we are the software engineers, we are writing, those are those kind of embeddings, right? So use of pre-trained models like OpenAI ADA or sentence transformers, Resonate, right? Or OpenAI Whisper for voice converter. So you can convert the different objects, real life objects into different numbers, right? And those can be stored like we saw in that books embedding in a three-dimensional world, right? Those are now points. Those have the concepts or the relationship implicitly taken care of with that numbers, right? Using Python encoder for using REST APIs with OpenAI or Hugging Face. These are the open source models we have hosted. Even we have Co here, which is also giving us the APIs that can also help us to get the embeddings. Like you can see, object 1, object 2, object 3, these are set of objects. There is a simple model, right? This model is the engine, which is already pre-trained with the infinite knowledge, and it is converting these objects into these numbers. Like object 1 is converted into 0.6, 0.3, 0.1, something like this. So objects as vectors now we are telling, right? This is how it is converting. All right? So why am I telling all these theories? So tell me about something I think is overlapping again. Tell me about something which is how search is changing, right? Because my topic is on LLM, how the search dynamics is changing across the world, right? So 1970, we started with keyword search and statistical ranking, TF-IDF. Like you can say we are using Lucene engine or we are doing some kind of Elasticsearch search engines. So those are using TF-IDF, term frequency, inverse document frequency, right? So how many terms, how many times this keyword is present in that document that is now coming up, as well as IDF. How many times that term is present in different documents. Suppose it is present in 10 documents out of 100 documents. In that way, we are finding the relevance of our keyword search, so that your Google search is giving you the results based on the ranks are coming accordingly, right? Google search is giving accordingly. Then 1980, people understood that the keywords are not only helping us. So we need to come up with something where human languages are now understood. Now whether the computer can understand us, right? This is where this introduction of NLP happened, right? Too many use cases where the words did not precisely match the query. We'll also talk about this in the next slide. 2004, autocomplete features started in the Google, right? When you start the search, sometimes you have seen that, okay, this kind of auto searches or the completion is coming up. This is where the autocomplete was started in 2004. 2005, ontologies and knowledge graphs came up, right? Knowledge graphs are nothing but it is the relation between two nodes, right? Related nodes, and so that you can connect the searches and say that, okay, this is related to this object and it will be presented to you. This is where the ontologies and the knowledge graphs came up. Relationship between different elements. But knowledge graph also did not scale because every day there is a new kind of, new changes are coming into the market, right? So how many times you will create the knowledge graphs? So that's where I think the LLMs or the large language models started up, right? Means in 2007 also it started with the AI ranking, with the reinforcement learning. The researchers started giving, a reinforcement learning kind of, you are saying that, okay, this search is not giving me the correct result. This should be this way, right? In that way, the search changed. Search changed until 2007, right? 2013, advent of vector search. What we discussed on the vector search, that started in 2013, containing the semantic meaning of words, right? So, still I'm saying that this is words. There is a difference between a word and a sentence, right? So, we'll discuss on that. Just keep in mind that word and sentence, what is the difference? 2013, what to wake and all, those are starting up. That is semantic meaning of the words started. LLM search with the vector database, this is the next generation search, okay? This is what is 2022 onwards, the world is moving towards. And there are lots of things happening around the world to change the dynamics of search because people want to be heard. People want to be, the machines should understand the deeper intent of the users, right? That's where the vectors are coming up with the large language models embeddings, all right? Okay, so we talked about words, right? The words and the sentence. So large language model, LLM enabled semantic search, what happened? It converted the sentence into some kind of numbers. Before, words were giving the numbers, right? If you see this word embedding problem, okay? So as I was saying, there was a word, no, I am good, right? These are the 4 words. I can create a sentence of no, I am good, I am no good, okay? Suppose no is represented as 1, 0, 0, 0. It's nothing but I have just taken one array of numbers and I presented that, okay, no is 1, 0, 0, 0, I is something like 0, 2, 0, 0, am like minus 1, 0, 1, 0, good is something like this. Okay, because computers will understand the numbers, right? Because they are very good at numbers. Suppose I created this sentence using this word embeddings. And what I did, I just summed it up. And it came like this, 0, 2, 2, 3. Because if you sum it up, how much is coming? 0, 2, 2, 2, 3, right? So, no, I am good is exactly represented like this. I am no good is also represented like this. Do you find any difference between these two sentences? Who are able to find? Okay, those are different, really different, right? No, I am good and I am no good, right? So, but the computer is not able to understand, but humans understood it. It is no, I am good, I am no good. So, how do we get that feeling into the computer, right, or the machine? This is where this large language model embeddings comes, right? This is where the large language model came, and the byproduct of large language model is the embeddings. When the unsupervised learning or instruct GPT happened, the weights, what we talk generally in the, like llama weights, right? Those are nothing but the embeddings, right? We are getting. So now what happened? Whenever we converted our sentences like, hey, what's up? Hi, how is it going? Hello, how are you? All 3 are now presented in nearby somewhere. The numbers now make sense, right? If we, as a human, if we see also, it is saying that, okay, these 3 are similar. And these 3 are similar, right? I adore my dog, I love my dog, I like my dog, right? These 3 are also similar. So now, because the large language model understood, and it is already pre-trained with lots of knowledge, infinite knowledge, it is now converting these sentences into the points in the three-dimensional world and placing them together means nearby somewhere. So that machine now understood that, okay, hey, WhatsApp is similar to hey, hi, how is it going, right? And it is also understanding that I enjoyed watching the World Cup, I love watching soccer, right? These are also similar, okay? So, but how the machine, means even we just presented as a human, we saw that, okay, it is nearby and it is similar, right? But we have to tell the computer that, okay, boss, this is how it is similar, right? These are the similarity distance measures generally we follow, okay, the computers follow. If you have ever watched Kung Fu Panda, anyone have watched Kung Fu Panda? So you understand this, people, right? So this is Master Sifu, is Po and Tigress, Laitong, I think Tai Long, and Mr. Ping. Right? This Ping is stepfather of Po, and cosine similarity is nothing but the angle, right? If you just go back, sorry. Oh, yeah. So if you just see that, okay, this is a graph, this is the two axes over here, x and y, and I just point is like a one line and this line, and I just say that, okay, what is the cosine similarity? It is saying that what's the angle between them, right? This is how we're saying that, okay, Master Sifu and Po are somewhat related, right? And Master Sifu and Tigress, this Po and Tigress, this is the straight line distance we are getting. This is angular distance and this is straight line distance. And this is a Manhattan distance, is like taking other attributes also into consideration. Like this Mr. Ping is nothing but a chef, but this Tai Long he's a very good fighter, but he is kind of shown as a negative character in this movie, right? So they are really 90-degree apart from each other, right? So this is how the similarity is taught to the machine. So this is how the machine understands, okay, if I have the numbers, how do I compare whether they are related or they are not related, right? If you keep all these things into mind, then how do you use this, right? How do you use this in this, or if you have these numbers, where do you store it? How do you keep it for an enterprise, right? This is where VectorDB, a new era of database, comes up. So large language model is nothing but, it's kind of an already pre-trained system, which if we fine-tune it, or if we train it again, we need to also bear some cost, right? So how is it that if we just convert the things or the text, whatever, suppose you have your documents or you have certain customer-related queries, all these things we convert them into numbers and store into a database, and whenever there is a question, we search the database and get the similar answers which were already given to the users, right? And use LLM to just generate based on those context, right? Because if you give the context to LLM, that is called few-shot learning, then you can generate the text out of it. Okay, so this is where the vector database comes. So previously we have seen we have key value pair like Redis cache and all, documents like MongoDB and all, graph database like Neo4j, Tiger, and some graph database, Gremlin APIs you can use. And this is vector database which is now coming up. Exactly.
If the words were converted into a vector, you could have also captured the position of the words. Was it not getting captured?
That's what I was showing here.
So the position was not getting captured?
Yeah, so if you see word embedding problem, no, I am good. I put the position, suppose 1, 2, 1, like this, -1, these vectors, and just summed it up. So no, I am good is converted into 0, 2, 2, 3. It is just sum up. And I am no good is also 0, 2, 2, 3. Okay, so the two sentences are different, but it is not really understood by the machine because it's the same number, right?
Thank you.
Thank you.
There's a small doubt here.
Yeah.
How about with the numbers if the data is in tabular format and it's all to do with aggregations and everything? How do you think that might be handled? I know if it's sentence or words, that gets converted to embedding.
So there is something called table LLM. Okay, there is a research paper on that as well. So if you convert these headers, header plus your value, right, as a sentence, you can convert it as. Suppose there is an employee name and a column and an employee organization or department, right? Two columns in the table. And you have the employee name also there and the organization is there. Just create a sentence out of that. That this is the employee name who is working in this department. And convert that into an embedding, store it into the vector database.
Now think about it being numbers. I'm sorry if I'm taking time. These are to do with any numbers like your financial figures, everything is in dollars, and what's going to happen with that?
Yeah, definitely. So we recently did a work on this in Tredence. That is called Data Whiz. We have a product.
What was that, sorry?
Data Whiz. We created a product with regard to your question only. What it does, it takes 3 tables, financial data. 3, 4 tables. You just ask a question like a Power BI NLP or Tableau NLP, but those are not quite advanced because we tested that also. But with our Data Whiz, what is happening? You combine, when you ask a question, it understands, okay, what columns are there in a table. I'll go there and I'll join and I'll get the insight out of that. Even you can get a trend out of that. Okay, at this time, this sales figure was this. It will give you a summary out of that.
Maybe I'll speak with you later.
Definitely.
Thank you so much.
All right, so thanks for your questions. We left at vector DB, right? Because there are numbers now. Everywhere is number, right? If you recall a movie called The Matrix, have you seen Matrix, the Matrix movie? So I think there are only numbers coming, right? so this world is now with numbers now. And we are heard or we are felt by the numbers. So every human being we have around 800 billion people, right, in the world, and they have different thought process. How do we store so many thoughts? We need if we really go for an enterprise level search or enterprise level database, like Sunset Inspired Shoes or something else, somebody else is typing, we need humongous amount of data to be stored, right? This is where this vector database comes. And it has picked up recently, 2-3 backs, people have started it, but with the advent of large language model, this vector database also came up into the picture. And it's rapidly progressing, and people are also researching more. So what is vector database? It is a purpose-built database to store, index, query the vector embeddings, right, generated by passing unstructured data through machine learning models. Previously, we have seen the database like Postgres, MySQL, SQL Server. What we store? We store the numbers, but not in the vector format. Rather, we store the text or the keywords, right? And descriptions of whatever, like employee name, what we are talking. But those are not helping us because to query the numbers or the 3-dimensional space vectors, we need some special database. This is where is the vector database coming up. It is already, you can say, common indexing methods like flat, kind of a brute force method is always there in the software engineering world, right? Facebook AI similarity search is there. This is another algorithm which is used for your searching algorithm and all. Hierarchical navigable small word. This is kind of which is nearby to this point that is coming up. Even if you are storing the data, maybe if you have worked on the big data world, you have seen that, okay, we have Parquet file or other file formats. Similarly, here for storing the vectors or billions of vectors, we're using scalar quantization, product quantization, or binary quantization kind of stuff, okay? Those methods help us to compress the data and make it search ready also. All right, so benefits of vector database, as I was telling, when enterprises take up the searches, then we need fast, low latency read and writes. We need usually vector stored, which is in memory so that it is retrieved very fast. And we need a reliable or fault tolerant system which is highly available, right? Also, it should be scalable. It should be horizontally, it can go and it can scale whenever the demand is high, and also should have security, right? Inbuilt security. Some of the vector database you can try out. These are the Milverse, Quadrant, Pinecone, Chroma, Elastic, VB8. Out of this, Milverse is open source, Quadrant is also open source, Chroma is open source, VB8 is open source. We have tried Milverse with a Kubernetes deployment to get a production system running, okay? Pinecone is giving you the cloud version of vector database, which you can use to store your embeddings, right? Elastic is Elasticsearch, what you know. So that is also have vector database. Even recently, Postgres has also come up with a vector database of their own. Architecture. What I'll do with this vector database? Something I have to do, right? So every application needs a database, and there is some kind of server layer, and there is some kind of UI layer, right? So you have media, you have some application code or whatever you want to put. You have the engine, which will, the large language model engine, which is converting this media and application or whatever, your text, into this kind of numbers, and this is getting stored into a vector database now. Okay? So this vector database is called by the first API layer, or Node.js or Golang, whatever, Java. These are the clients for your vector database. So this will call the vector database, get the, suppose, top 3 results, whatever you are getting, and it will just ask the embedding model again that what was the query this user is asking. Then it will give you the answer, right? Based on the context what we got from the vectors. This is how it works. But if I just double click on this architecture, it's not going, okay. So just that was the high level architecture. Let's talk about the business use case. Suppose you have some PDF files. Every organization has lots of knowledge repository, right? You have PDF files, you have contracts and all. How do you then use this embedding based system to search your organization's data? Every organization has HR data, or suppose I want to see how many leaves are there because I want to travel, right? So what is the leave policy? So if I want to search, I have to go to HR portal. Then I have to find out what is document. I'll download it. Then I'll read it. How is it that you have some system which is answering the questions based on the organization policies immediately, right? Also, same system is answering about the technologies what other people have also created, because the other developers who have created the code bases, that is also fed into the embeddings or vector database. This is where this architecture comes, where you have the input files, right? And you extract the content here, okay, through using a Python or something. Then you just split, because large language models work on a contextual window. So you split it to minimum context, or around 250 word or 350 words, something like that, depending on your model which you are using. Then you use a chunk transformer, right, which will convert these chunks into embeddings, right? Whatever you thought of the numbers. Those numbers will be fed into the vector database. This vector database now is able to answer the users, because whatever user will ask the query, that will also get converted into some kind of number. That number will be masked into the vector databases tables or the rows, and it will give you the answer. This is how it works. So this is where your document or contract search happens. Or also you can utilize this for any kind of financial domain, contracts reading or SOW reading, or like invoice reading. Everything you can do with this architecture, okay? So Tredence also came up with a very enterprise-ready architecture, because we wanted to also include the caching layer, the API plugin layer, the you can say logging and all these are different, right? Like contextual data, data pipelines you need through Databricks Airflow or any unstructured data is coming. Then you have some embedding models, which is like, as we talked, OpenAI, Palm 2, Hugging Face. Even we are exploring AWS Bedrock, which has various open source models. And we are using Milverse, also PG Vector we are using. And orchestration we are doing with the LangChain, Llama Index, ChatGPT also we are doing. So LangChain primarily is our framework to combine the LLM stacks, right? So this is how we are orchestrating. Playground, we have a GenFlow. It is kind of a low-code drag-and-drop LLM application builder. We have what we have built now. We have also put down our marketplace stuffs into this GenFlow. You have app hosting we are doing with the Kubernetes, Streamlight, Azure App Service we are using, and LLM Cache. LLM Cache also a new topic which is coming up like a GPT Cache, where you don't have to again convert your queries into different numbers. Rather, the caching layer is already keeping the numbers for you to be faster retrieval mechanism. Logging and all, we are using MLflow. Validation, we have Microsoft guidance because LLMs generally hallucinate, right? How do we validate or combine or restrict their scope? This is how it is coming. And LLM APIs and hosting, this is how the Azure, OpenAI, or Palm 2 from Google or Hugging Face, they are giving us the APIs which are hosted. Business use cases. So if you now think of the first slide that Sunset inspired SUS, right? So now we can see that, okay, natural language-based semantic search you can do. That it is, the search is filling your words or sentences what you are writing. Image, video, song search recommendation. Like Netflix is giving you the recommendation, right? This movie is kind of similar to that movie. So those recommendations also you can easily do right now instead of doing any kind of, again, modeling and all, because your LLM is taking the image and converting into some kind of text. Now it is ready for recommendations. Autonomous vehicle, same image concept. So it is also trained on understanding what kind of scenarios are coming, different frame rates are coming, so that autonomous vehicles are getting driven through the power of vectors. Fraud detection, kind of you can say, when a user was doing some transactions, their different parameters are combined together, and it is now also presented in a 3D world. And these numbers are not matching with the today's transaction, suppose, because with the cosine simulator or the Euclidean distance, then definitely there is some kind of fraud, right? This is how you can use the fraud detection. Also, e-commerce product recommendations, which currently are also happening, but with the power of LLM, you can do it at home today also, right? If you just learn some kind of 10 lines of code, then you can also start doing all these activities. So let's see, I just grabbed a picture of how one Redis-based search engine is working, right? So you're seeing that this is how our e-commerce apps look like, right? This is Adidas men's shoes, some Puma, these are the shoes, right? And you can see there is a view similar by text or by image, right? Sometimes we see that, okay, I like this kind of sandal or this kind of shoe, and I want to find out, is there any other similar image based shoes from different brands? Okay, if I click on that, then you can see there is a numero uno brand, something is there, something from numero uno, right? So these are the things you can do by your similarity search by image. How do you think that if this kind of search mechanism comes to your Amazon or Flipkart or Myntra app, that will help you more searching similar designs across different brands, right? This is how a small application was built. So I thought, let's have a GIF and I can show it out. Okay, so I think I took more time, but I'm done.
Quick question.
Definitely.
Yeah, so it looks to be simple when we start experimenting, right? So what we were experimenting is, thank you. So what we were experimenting is all the open source model. So how do we know that these vector database are right in terms of giving the search values? Because we did the same policy experiment when we uploaded it, sometimes it is giving it right, but sometimes we are seeing it is hallucinating, even though we have given the context right. So how do we tackle these kind of problems?
Correct, correct. So hallucination comes when you are generating something, right? Correct? So hallucination is kind of when you are summarizing something, then the LLM is bringing infinite information from the world and it is generating, because it is trained to generate the next word by seeing the context, what is there, right? This is how the transformer models work. Vector database is nothing but storage. You have converted your text into some kind of number so that it is really helping you to understand what kind of emotion you have put into your text, right? The better you train your LLM models based on your domain, suppose you are from the e-commerce or finance, the better numbers will be generated out of that, right? Because the numbers will be more inclined to your emotions, because it is more domain-based trained, right? So this is how it works. So you need to train according to your domain so that the embeddings is getting out, and you can store into the vector database.
So if I understand it right, so ideally the open source LLM models, we need to train them with the
Correct. With
the domain
maybe
data
maybe
set.
it will
Okay.
perform better than your OpenAI models.
Yeah. Okay. We'll try. Thank you.
Thank you.
Hello. Yeah. I have one question regarding the embedding. What could be the optimal size of the embedding? Let's say if our corpus is very less, then with the less embedding size, we can go ahead. But if the corpus is very high, I believe we need to get a better embedding.
Really deep question. Thanks for this. What I have seen, the more the knowledge base to train the large language model, right? The lesser is the size of the vector embedding, right? The more the knowledge base, the lesser is the embedding comes up, right? So it's better, and also with the binary quantization and with the product quantization, you can size down so that it is helping you to search, right, on these quantization methods. So we can double click on this, but it's again a vast topic.
Yeah, thank you. Thanks a lot. There is one more question like in line with this. This is regarding the indexing. So can we try any wrapper layer of indexing on top of vector databases? Like
already vector database has the indexing mechanism, because Facebook enabled FAIs, right?
Yes.
That is already been created. It is taking the similarities, what we saw that, and it is already given you the wrapper. But if you want to create your wrapper, that also you can.
On top of existing embeddings, like in simple databases, we can create new embeddings like wrapper indexes on top of existing embedded.
Definitely, because vector database is nothing but if you go to their open source code, it is written in Go, or it is written in, I think, Rust also somebody have written some vector database. So you can also contribute into that database. You can write your wrappers. You can name it in your name also, right?
That would be a very big topic.
Thank you.
Thank you. Thanks a lot.
One.
Nodi, enterprise document search. We have huge repository of documents across the organization. Been into this world since 2013, because 10 years documents we have here and there scattered. So my team thought that, okay, why don't we create some kind of knowledge base so that people will ask in one place, like HR document or your text coding document, whatever, whether we have a demand forecasting code with us, or do we have supply chain sales pitch document. Everything is now created into a vector, means assembled into a vector database, so that whenever you ask the question, it is giving you the document, and it is also giving you the link to that document. So you can click on that document, it will take you the proper place where you have asked the question.
It's being used in
it's been used inside Tredence. And there is another thing called LLM BI, what we have done. It's combining multiple tables and giving you the insights out of that. Suppose you ask the e-commerce sales table that what is the trend in my sales. So it will tell the insights by joining multiple tables. This is another case. There is third one is we have a framework like a LangChain. We have a flow-wise, maybe there is another low code based LLM stack creator. That's what also we have created. Even we created our own AI workbench where you can have the co-pilot, likes of GitHub co-pilot. You can ask question, it will answer all the questions answer. Even it can generate.
The way we have been using LLM is to do fine tuning, right? You have it, some data and you do domain adapted pre-training, right? Now with the approach that you are suggesting is that we don't need to do any of that. We can store all of the embeddings in a vector database, right? So rather than,
So rather than retraining it multiple times so the large language models give us that flexibility, right? Because they have invested huge money. And we are the users now. How do we cheaply use it? Because the cost-effective applications we have to make, right? So if we can get the embeddings out of the LLMs what is already trained, maybe if you want a healthcare-based LLM, you have to train it according to healthcare, like Hippocrates AI, or they're also doing for healthcare, like Bloomberg has done for finance. So if you have that kind of money, then your embeddings will be better. You don't have to again ask the LLM and give the tokens, get those money, because the tokens is also costing us, right? If you ask the API, how many tokens based the cost is happening. So with vector database, once you have got the thing, you can directly get from there.